4.4 is physical and chemical changes. Our outcome is I can explain the relationship between macroscopic characteristics and bond interactions for chemical and physical processes. So, processes that involve the breaking or formation of chemical bonds are classified as chemical changes, whereas if intermolecular interactions change, those intermolecular forces, such as during a phase change, that's going to be a physical change. Some processes may be ambiguous, so they often involve breaking of chemical bonds as well as the formation of intermolecular attractions. So we want to identify these as chemical or physical. So an acid is added to water and the pH decreases. I would classify that as chemical because in order for the pH to decrease, that water must be acidified by the presence of H plus ions from the acid. So that chemical bond that's holding that H plus ion onto the acid molecule has to be broken. Whenever we dissolve some solid NaOH in water, the temperature of the water increases and the pH increases. So I would also classify this as chemical because we are changing also the pH of the water. If this were just dissolving in water and had no impact on the pH, there'd be no reaction there, and we would probably classify this as physical instead. Solid copper sulfate crystals are ground using a mortar and pestle. The crystals change from dark blue to light blue. So that is going to be a physical change. Sometimes a change in color accompanies a physical change. So here in this case, by grinding up those molecules, you're changing the way that light interacts with them. And the particles are much smaller, much finer, so light gets scattered. So we get that sort of light blue color. Bromine gas to bromine liquid is going to be a physical change. If we react silver ion and chloride ion to form silver chloride, that would be a chemical change. So in my physical change here, I'm just changing states. So I'm going from gas to liquid. But in my silver chloride reaction, this is actually a net ionic equation for the formation of silver chloride precipitate. If potassium chloride is dissolved in water, so that's ambiguous because we're breaking ionic bonds to dissolve this compound. We're also forming intermolecular attractions between the ions and the water molecules. And if we were to boil the water away, we're going to be left with that potassium chloride salt. When water is boiled on a stove, that's a physical change. It's still water before and after. It's important to note that inside of the bubbles in the boiling water is water vapor. But if we have water undergoing electrolysis, we form something new, particularly hydrogen and oxygen in a 2-to-1 ratio. That's going to be classified as chemical. So during a phase change, heat is added to increase the kinetic energy of particles. So as those particles absorb heat, they start to vibrate and wiggle around more and more. Their molecular motion increases. So this weakens intermolecular forces, allowing the substance to melt into a liquid or boil into a gas. If we do the opposite and we remove heat by cooling, those particles are going to move more slowly and interact with each other more strongly, and that will strengthen the intermolecular forces in the substance. So for each of these, we want to indicate if intermolecular forces are getting stronger or weaker, increasing or decreasing for each of these phase changes. So solid to liquid is melting, sometimes called fusion, and that is a decrease in intermolecular forces. We have to weaken those attractions so that our solid can become a liquid. Liquid to gas, so we'll call that vaporization when it's occurring at the boiling point. So if you have water boiling on a stove, and we'll call it evaporation whenever it occurs at ambient temp. So if you have a puddle outside and the water evaporates. So for both of these, my intermolecular forces are going to be decreasing because we're going to a state of matter where there's more molecular motion. When we go from gas to solid, we call that deposition. Gas to liquid is called condensation. So in both of those, we're going to a state of matter where there is less molecular motion, less molecular freedom. So that's going to be an increase in those intermolecular forces. Solid to gas is called sublimation. Good example of this would be iodide crystals. If you disturb them, they'll turn into a gas. And so that is going from less molecular motion to more molecular motion. So that is going to be a decrease in their intermolecular forces. Liquid to solid, solidification or crystallization or freezing, we have an increase in intermolecular forces. So when a salt dissolves in water, the bonds that are broken are ionic bonds, and the new intermolecular attractions that are formed are between the ions and the water molecules. So that would be called an ion dipole interaction.